we can start now. So today we will go through the lab for lab 6. Basically this one is this the correct one? No, this is the wrong one. This is assignment 6, not lab 6. No, okay. We'll do assignment 6 first then. So this is for assignment 6. For assignment 6, what we have to do is we have to re-implement vector classes. So as we all know, C++ has this vector class. It's a very useful container. Works very similar to array, but it's more useful than array. You can store different data types. Instead of array, you can only store like maybe like int or pointer to an array. Int or int pointers, yeah. And outcast, just simple data type. But for vector, you can store many more, right? So for vectors, basically this is what's given to us. We're gonna have to implement this. Pretty simple. So so for this one, right? So these are the header file that's given to us. We are using something new today. New for this lab, for this assignment is the initializer list. So for this initializer list, right, it's basically a list. Maybe I can draw it out. Let me see. Okay. So it's basically it's like the curly bracket list, right? And then you have like this is your first data, this is your second data, this is your third data. So with this initializer list, we can construct an array, right? So we will see how we're going to do that in this lab. Okay, so PDF. Let's go back to the PDF. So we will construct a vector using initializer list, and we also use the copy assignment operator using an initializer list. Copy operator, assignment operator, not copy assignment. Copy will be here, and then all these other functions that will be helpful. So that's basically it. If you want to go through more of the stuff, it's how to grow a vector. I will go through all this. Okay, I'll make it simple, make it easier for you to understand. But you can still refer to this. I'll still refer back to this so that you know what to look for in the future. Okay, so let's start with the constructor first. So this is vector file. Where's my vector? Okay, so this is our HPP. Oops. Okay, so remember to comment everything. So for this one, I talked to the lecturer. What he mentioned is that you have to have a function documentation for each thing. Even a simple constructor, you have to have something. I can do one for you so you know what it looks like. So for constructors, we must have a simple brief. So this is for .cgen. So we just write this is the default C4, and that's it. Then you have to do one for each. Right? It's gonna be fun. You're just gonna have to exercise doing that. Right? So for the screen looks weird. Let me fix it. Oh, it looks fine my screen. Okay. So we have the default CTOR, nothing to do. It's just the default. It will initialize default. Default meaning it will initialize it with 0. This is very useful because we're going to do a lot of special stuff that will require not really require, but it helps when you initialize everything to 0. I'll show you it later. This is the explicit constructor. You put implicit things to show that you are implicitly defining a constructor of size type n. So this is the size of the vector that you will initialize. Now if you want to put a list inside the vector, just initialize it with a list. You can do this. And it's an in. Because for now you just use in. And then this is a copy constructor. You copy one value of a vector to another vector. So all this you are all familiar with. Destructor, you have to do something special with it. I'll show you later. So it's not just default, but it's calling the default destructor. So for copy assignment, we are just using the equals. This is not really copy assignment. You'll see later that we're doing something special, like not your typical copy assign idiom that copy swap idiom that we have been doing. It's a bit more complicated. So this is our assessor. Normally we use this to assess the data type we want, because like the vector they are arranged in sequence. So to assess the data type, you use the operator plus whatever value you want inside to take it. So one for a simple volatile, a simple one that's not cons, another one for cons. So when you want to have something cons, just put a cons behind it as well. Right? These are our member functions that we are going to use. Pushback. Pushback basically you're all familiar with. You just push back a function to the back of the vector. You store a function in the back of the vector, so the vector will grow by 1, and you put in the new value in. So for reserve, right? Maybe I can explain it using. Actually, the PDF comes in handy for this one. Oh, let's go back to the PDF. Oops, that's the wrong button. Let's go back to the PDF. Alright. So for resize, so this talks about how to grow our vector, right? So if the vector is static, it's not going to be very useful. So we want it to be able to grow as you put in more values inside. Of course, it's quite hard to manipulate the memory unless you can't just blindly add in values without manipulating the memory. So for growing a vector, we have stuff like pushback, we have stuff like reserve, and we have stuff like new size, resize. Yeah. So all these three main functions will help us grow our vector. And then the more useful one is copy. Copy is going to help all these three. This is a function I added in, but basically this copy function is going to help with everything else, including some of these functions here. Okay, so now let's talk about how we grow our vectors. Yeah, let's see what the video starts with. Oops, that's the wrong one. Alright, so growing a vector. So when you initialize a vector at first, right? When the compiler initializes a vector at first, what the C++ standard library do, right, is that they will create an array. This is the data that you want, and this is the whole space, and there's an extra space here, okay, so that you don't keep allocating data. Let's say if you initialize a space of 5, right? So these are the three data. These are the three private data that vectors normally have. So let's look at our whiteboard. Where's my whiteboard? Wait, yeah, my whiteboard is missing. Oh, great. So we have okay. So let's assume, since we already have this, let's assume this is our vector. So the data type, the data is this data will point to the first element in the array, not in the array but in the vector. So this is our data. Our size of the vector will be the number of elements inside, right? This is our sz equals to number of elements, right? But we still have an additional variable data member that is called space. So what this space is referring to, right, is referring to the space of the vector space, vector memory, right? So if we initialize initial vector with size of 3, the space will be 3. But let's say we just want to add in one additional value. Let's say we want to grow the data into 1, 2, 3. So we put in 4, right? This will be a pushback 4. Okay, so you push back and in 4. So now the size grows, right? So the size now equals to 4. So this one used to be 3, now it becomes 4. But space wise, right, instead of it being 4, right, what we're doing with space, right, what we are doing with space is that we are, okay, this is size 3, and then we have a space, we have this space. Okay, they are the same. Just imagine them as separate entities for now. So this is our size and this is our space. They're actually pointing to the same address. So no, they're not pointing to the same address. Don't think of it that way. Just think of them that they are supposed to be overlapping, but right now they are not, so that I can visualize it easier. So this space is able to contain 3 sizes of 3 elements. So let's say we push back one value, 4, right? What's happening, right, is that we're not just increasing the space to 4. What we are doing, right, we are doing this one 1, 2, 3, then here we have 3. So now there's an empty space of two more elements. So what this helps in our programming, right, is that you don't have to keep allocating new memory every time you push back a value inside. Right, this saves on time. Doesn't save on space, but it saves on time. So every time you're just checking, if I push back one, what happens? Right? If you push back, the size increases, but the space, what you do with the space that you check, if space equals to size, the old size, if space equals to the old size, okay, then I'll just erase this. This might be misleading. So what you do, right, if you push back, you just check if space equals to size, then you reserve. You run reserve. You reserve more space. So reserve will take in the value. You reserve 2 times size. Okay, that's it. So now you should actually see that the space here is 3, but it's 2 times here, so it becomes 6. So this is what we are doing for reserve. For resize, right, we won't be calling this function. This is up to the client, to the driver to run the resize function. We'll go through this later. This resize function, right, relies heavily on the fact that the vector is initialized with empty values. So when you run this constructor value, you should expect the vector to equals to 0. No, don't put that. That's misleading. To 0. Okay, we assume that because this will help us a lot. Alright, let's go back to the code. Let's go back to the PDF. Okay, PDF time. So this is what he's trying to illustrate. If you just construct with a default value and your size is always equal to space, right, there will be no free space. So what we do when you push back is you actually effectively increase the size. See, the size here is 5, so you increase it by another size. You increase the space by another size. You keep doing it, you just take up a lot of time. So what we are doing is that we are doing reserve. We're running this function reserve whenever we call pushback. So what reserve here say, if you read the thing, you can just summarize it. There is you will input a new alloc inside that tells you that how much you want to allocate, right? So depending on if the new alloc will be the new space, the new memory space. If it equals or is less than the current space, right, you don't do anything, because for now we don't decrease the memory space. It's a bit out of our scope now. But if new alloc is more than space, you just allocate the new block of memory. Okay, it's a new block. It's not just a new. It's not just increased by 1. It's a whole block. And you don't need to initialize initialize the elements of reserve space, because it's already initialized to 0 when you when you do when you construct your original vector. So the original vector is constructed with all elements 0, right? So you just copy the old elements. When you copy all elements, right, what you're doing is you're also calling the copy constructor. Yeah, and then so it will just, it's all done by you. It's actually done by it. It's all done by the code that you already been built up from the start. And then you just delete the temporary array that you created. No, you store it into the new array, then you delete the old array, the old vector. Make sure you delete. If you don't delete, right, you're going to run into trouble with boundary. Whenever you assign new stuff, whenever you copy new stuff, delete, so that you don't run into memory problems, memory leakage. And we just change the data of the old size to the new, of the old vector to the new vector, because it's actually creating a new vector. And then you just increase the space to the new alloc, and then you increment alloc by 1. This one is just to keep track of how many times you allocate the memory, which is what this lab will keep track of, to see how well you are doing, see whether you understand what's going on. And then now we have resize. Resize is a very simple function. It might seem very hard to understand, but I can just show you. Okay, we just read through briefly, then I'll show you the code. Very simple. The new size, and if the new size n is larger than the old space, actually I can show you the code like that. Some magic. Hold on. Oh, is it too small? Can you guys see? I think it's too small. I need to zoom in here. It's 200%. Yes. Alright. See, we're always learning. So for resize, it's just 3 lines. It's what the teacher expects as well. So for this first one, the new size n is larger than the old size. So what we'll do is that we just change the SZ. Well, there's nothing much to change. But okay. If n is larger than the old space, you just allocate new memory. So just reserve n. Just call the old function that we have already created. I didn't go through this one. Never mind, I'll go through resize first. Then for second one, you don't need to do anything. All you need to do is just check if the size n is larger than the old size. Then all you need to do is just change size to n. That's it. That's it. Nothing much. So over here, just size equals to n. And then since we already initialize it with 0 from the start when we construct, it won't be a problem. We won't have garbage values. So this one, nothing happens. If the client want a new size, but it's already the same as the old size, you don't do anything. So there's no line of code that represents that. Okay, then for the new size, n is smaller than the old size s. So like what I said before, we are not destroying elements, we're not deallocating anything, because it's beyond the scope of the course. So what we just do is we leave the memory alone and just reduce the size. Just reduce the size to n. So same thing, size equals to n. So basically they are both doing the same shit. But there are 3 conditions, so we have 3 lines. So yeah, the lab hint us that the function requires no more than 3 lines of code. And it gives us a hint of how to implement each one. Second case is easily dealt with if we initialize it with 0. Third case doesn't require any work. And the fourth case simply reduces the container size to n. So size equals to n. Same thing as here, size equals to n. For the first one, yeah. Yeah. Okay, let's go through the reserve since I forgot. Sorry. Okay, so you can see the comments here. So the way the comment works, right? The top part we just ignore. If new alloc is less than or equals to space, just return. Okay, we are returning nothing, so it's fine over here. For this one, so we just create a temporary pointer with a value type new alloc. This value type, right, I will go through it later. Just keep in mind that this value type, right, is a current type for the vector. So let's say if I want my vector to be car, the value type will equals to car. If I want the value type to be int, a vector of ints, the value type equals to int. But we don't want to, like, let's say we don't want throughout the whole thing, right? We don't want to, let's say if we change our vector type to suddenly become int when we were originally car, you have to change every single line of code that contains int. But you need to make sure that you're changing the right thing as well. So it's quite difficult. But if you use typedef, or C++ way of typedef, you can just assign it to one typedef value type, and then if we want to change the value type, we just change the definition of the typedef, and we are good to go. I will show it to you now. So it's in a HPP. Here, we're just using value type int. If we wanted to change to car, we can just change to car. Right? So that's it. Then from this value type, we can just build the rest of our stuff. Reference, const reference with the ampersand. Then pointer, const pointer with the star, asterisk, and then that's it. And then size type is size t. This is the data type that you use for our size. It's very good to use. You should use size t for anything related to containers. Alright, so where were we? Yeah, over here. So we create a new array. We create a new temporary array, and then we store all the current data into the new temp data. Then once we finish storing it, we delete the old data array, and then we change the pointer of the old data to the pointer of the new data, and then the space we will change to new alloc, and then for allocs we will increase. So this is the number of allocs that the vector, that this current vector class has this current vector object, the amount of allocs that it went through. Okay, so okay, then if you're done all these three, right, you'll be able to do pushback. So pushback, very simple. If space equals to 0, you reserve 1, right? This one is explained in the over here. That's it. When we first think of it, pushback will be a complicated to implement, but since that we already implemented reserve, it's going to be quite easy. So you can read through this but I will go through this only. So if space equals to 0, right, you just reserve space on one element. It makes sense, right? Because you at least want the vector to contain one element. If it's 0 element, it's really a pointless vector. Why are you even creating it in the first place? And then the second one, if you want to push back something, and then but you realize that your size is also equal to your space, so it means that you are running out of space again. So you need to increase the amount of space. So what you do is you just increase the number of space. You just reserve space for 2 times space elements, right? That's done over here. If size equals to space, just reserve 2 times space. Then you just send this value to your reserve, and then your reserve will do all the magic trick, right? Very useful. And then once you really increase the size, you make sure everything is good. You just go to the end of the vector. This end we already declared. Again, this is not the standard library end. This is the end that we are using. Is been done over here for iterators. Nothing much to do. You just need to declare it. You don't have to do anything to define it. Yeah. So vector n equals value. Right. This is how you push back, and then you increase the size since you have one more element now. Okay. So these 3 functions, very simple. This is the core of your vector function. Now, what will help you with these 3 functions, right? Actually, this one is for the client to use. This is what you will also use. Actually, you don't need to use this since this one is your assessors. Except for this guy. This guy is a function. These 3 are assessors. Size, capacity, allocation. This is for your client to get to get the data that they need, right? You see in vector, you see in the driver, in order to get, let me find what's the function called? Size, capacity, allocation. Okay, size. Yep. See, they are using it because they don't have access. The only way they have access is if they call it the function. But we have access. I mean, because we call it we put all our functions. Oops, that is unnecessary. We put all our functions in our member public array. So they are member functions. So they have access to all the data members that are declared private here. Okay. So I think you guys can go through. Let me explain this. Yep. So the client will want to know the size. The client wants to know the current capacity. So if they know whether if the memory is too big, and then they want to know the amount of allocation that they've done to the vector. And then these are the iterators that we will use. Very simple. You can just do one line. If you want the beginning of the vector, you just return the beginning. If you want the end of the vector, you just return the beginning plus the size. Then you just do the same for the rest. Right? Easy stuff. Yeah. So just these 2. Then just copy the rest. And remember cons. Okay, okay. You can play around with the code. I think this code is not very optimized. Then let's go through constructors. Yes, let's finally start with this copy assignment. Copy assignment will be last one. So for constructors, we will be here, right? So before we can really start testing the three functions, we need to do this first. Okay, so default constructor, nothing much to do. You just construct. So this is the default constructor. This is how you call it. Are you guys okay? Restart. You guys can talk in the chat now if you're still not familiar with how classes work. If you're still struggling with classes. Anyone? Cause like I don't mind explaining it in depth. If no one got any problem with classes, I'll just assume that you guys are okay with it. Okay? So it seems like everyone's fine. So vector scope back, then you call the default constructor. Yeah. Then for size, since it's a default constructor, we're just going to initialize it with default values, right? You can skip this step by just putting the default value over here, but you won't be able to access this, so it's not very useful. Might forget what I just said. You can't apply it here. So for size, just initialize it with a default value of 0. So because there's nothing inside. Space, nothing inside, so 0. Allocation, you haven't done any allocation yet, so 0. What's the pointer? You're pointing to nothing, so no pointer. Right? Then just put the braces here, and that's it. That's your default constructor. Oh shit, it's blocking. Just turn it off. Okay, sorry. So data now pointer, and then just put these two braces at the end. This is basically what Prasanna means when he meant that he typed like that. Then he put empty by design. Empty by design. Right? Because when you call this function, you're not doing anything. You're just initializing the value, which you can do outside the function. So yeah, so you just leave it. Clean code, right? Clean code is very good. It's what the professors crave. So for this one, vector, now we're calling the function of our this our normal constructor, our explicit constructor. This one's when we explicitly want a value to be initialized. So given a size type, let me just close this. Given a size type of n, we're going to initialize it with the standard size, and then the space will be the amount of the initial size that we have. And then since we already allocate, we are starting to allocate memory into the vector already. So we construct it with 1, and then this is our new allocation. So new value type, and how much are we allocating with, which is size. I mean, it can be n also. It can be n if you want, but let's put it as size, so it's more consistent. You can also put this as size. It's the same thing. Yeah, it's the same thing. You put n, you put size. It doesn't matter. It won't matter. It won't matter, right? I can test. On, and then make this. Yep, I run the diff and nothing, and there's no error coming out. Oh, you guys can see. Right, I make this. I run the diff here, over here, and then there's no line coming out, so it should be fine. If maybe I can prove whether it's not fine. I can change this. This is when you don't understand. Okay, sorry. This is when you don't understand what you're doing. If you are already allocating value here, but you put it as 0, then it doesn't make sense. So it will be an error. So let me just go here. It won't be an error in compiling, but the error will be in the logic. Hey, it's still correct. It's not right. Oh. Oh no, I shouldn't. It doesn't call here. I think it calls over here. Yeah. Yep. Yeah, you see. You can't really see. Alox equals 0. But when you assigning a new value inside it, you should expect it to be 1. Yeah. There's more errors here at the side, but it's covered up. You can't really see. Okay. Let's mirror back the correct value. Okay, so for initializer list, let's see how they call it. Then we get a better idea. Void test. You guys should by now know how to do tests. So I don't think I need to go through that. Do I have to go through that? You guys want me to go through that? How to like test the driver? I think you guys should be okay. But one trick I saw most people never implement. That's a trick I can teach you. Okay. I just go through once. Let's go through once and then I confirm that you guys are okay with it. So let's say you want to just test, you just started and you just want to test test push. So what you do, right? You just highlight all the functions here. What you do is press Control. You can try it now. Control / and all of them will be commented out. Then you just Control / here, and then make sure you're just running one program, and then just Control / here, and then when you make, you shouldn't complain. They complain about print. Okay, we cannot comment this one out. White print. Alright. Okay, we're using this. Right, okay, no complaints. So just quick and easy way to comment things out. So when you want to comment, when you want to use them back, right, all you need to do is just like that. Don't even highlight, just Control / then you just like comment it out, comment it back in. Easy stuff. Right? No response. That's fine. So for now, let me just put everything back. Right, I can't do it that way. Here. Okay. And then all hide back inside. This is what you call a grower. They're not showers. Okay. So from test push, they do use. So this is the standard initializer list. Initializer list initialization. So what you're doing is that they're using a list and the list to initialize the thing. So when you get this list, right, you need to know how to store this data properly. Alright, so let's look at let's bring up the PDF again. PDF over here. It shows our data, our private data. So size, number of elements, you can easily deduce is 5. For the space, it's 5. Very simple stuff. And then for the allocation is 1 because you are allocating one new memory. And the pointer data will be the address of the first element, which is the new array that you create. But there's a trick, because when you initialize an array, right, normally what we will do is that you will use the pointer, you will increment it, but then let's say you initialize it new data. Let's see here, like data new value type in, right? But you want to put stuff inside the thing, so you just increment data. But what happens? What's happening, right, is that you're incrementing the data as you store value inside, but your pointer won't be the address of the first element anymore. Your pointer will be the address of the last element, and you will lose the pointer to the first element unless you do some mathematics. You can get it back, but that's not a very smart way to do it, right? So what I did is I used this copy function. I sort of created, because I noticed that I was doing the same thing over and over again. so might as well just use copy, a function to do everything. So the same thing, braces, right? The way they work is like a normal function. Normally it's like that, and then you put the what you call this? For each line you put the semicolon. I even forgot what semicolon is. Right. So for each line you put a semicolon. So this is just a single line. Oh shit, it's been blocked. This is just a single line command. Copy. If I want to create a new stuff, I want to copy the stuff in the initialization list into my data array, and I will do it using copy RHS. RHS is the parameter of the list. I just like to use RHS because you just copy paste easily. Same thing for this. Okay, so let's go through RHS. For initializer list and vector is initialization. There are a few differences that you have to take note of. So for the initializer list, right, we are using this header file, right? This header file provides a lot of useful functions that we can use, like size. So if you want to know the size of the list, you don't have to count it one by one. You just call the function, and this will be initializer list dot size, and then it will give you the size. Right, simple stuff. So now if you want to do it with a vector that we created, we created a vector with size, so we know what the function, we know how to call the function. So just dot size, and dot size. That's it. Then you just put the array inside here, just like you put the list inside here. Alright, so let's go through the copy. Alright, so they're both the same. No, they're different. So there's one copy for vector and one copy for list. Okay, so for the copy for vector, what we're doing here is that we're creating a temporary function, a temporary temp pointer that points to the first element of data. So what this helps us do, right, is that we don't accidentally increment data all the way. Let me just draw it out so that you can imagine. Whiteboard. I guess I don't need. I can create a new. Oops, wrong one. Excuse me. Yes. Alright. So what you're doing here, if I can just find an empty space. So what we're doing here, right? Let's say if we do the shallow way, like if we're not thinking too hard about our stuff, this is our data pointer, pointer that points to the first element in the array. So 1, and dot dot dot. Yeah. Okay. First element in our vector, right? So this data pointer points to the first element in our data, in our vector, and you want to store values inside data. So every time you store values, you might originally do it like we do a for loop. You can do a for range. We're doing a for range loop here. So it's for loop, for range. You guys know about for range, right? If you're not sure, I think a quick Google search can help you. So since the data inside is in, we just use in, and then we just assign it to a random value, I, or maybe for easier understanding, I'll use value. And then for every value inside, actually no, not inside data. Okay. For every value inside this, this is our either our vector or our init list, right? So for every value inside, I'll put this as RHS. Okay, for every value inside RHS, what we are doing is that we are taking data, the value of data, we are going to increase, we're going to store this value inside data, right? Then we're going to increment it afterwards. So what this does, right, is that like I said before, your first pointer is here, and you want it to be your first pointer. But if you're doing this plus plus, right, your data is going to move all the way until n, and then what? That's wrong. That's a wrong implementation, right? And then you want to move it back. But it doesn't make sense. Why must you do it twice? Why not we just save time, save compilation, and instead of using data, let's loop it, and then let's move this down. Instead of using data, why don't we just create a copy of the pointer, temp, and then we will construct it to be the copy of data, right? And then we just increment them. So to understand this, right, data points to the first value, and now temp also points to the first value. So temp points to the first value. But to store all this value, right, all you need to do is just to increase them, just like oh shit, forgot about the size. Just like temp all the way to n, and then as temp move along, you store the value inside, and then that's it. Your data is not moving. Your data is stationary, and you don't have to do anything special. And this is clean. This is clean code. You don't have to do like, oh, data move forward, then data minus size. That doesn't make sense when you read the code, right? Why are you minusing size when you can just, it doesn't make sense. So when you do this, it makes more sense. Or you're saying, oh, let's create a copy to data, then let's move it along, and that's it. You're not creating a new array, you're just creating a new pointer, right? This is something that you should keep note of in the lab as well. Okay, so for in list, data list is the same thing, same shit, right? But because one is an in and one, they are basically, so what I'm doing here is just basically sort of function overloading, because it's a different signature but the same name and same return type. But remember, return type is not a function signature. Right? Yeah, essentially doing the same thing. You can use template for this, but we haven't learned it yet. I mean, you guys learn it now. You can try. You can use template for this. Alright, so I went through everything already. There's something I'm missing. I'm missing something. Yeah, very, very important. Oh, I think it's inside one of these. Okay, so destructor, if data, because okay, normally when you run something that you guys should know, I don't think it's common knowledge because sometimes skip through. When a class go out of scope, let's say you initialize it here, right? So the scope will be in test push. If it runs out of scope of test push, right, it will be automatically destroyed. You don't have to call delete, you don't have to do all that. You will just, the compiler, the link compiler, yeah, not linker, the compiler will just call the default destructor, and here you will define the default destructor using making sure that it's within scope. Then because we have allocated memory, make sure to delete it. If we didn't, right, you don't have to do this. Okay, but since we did allocate memory, the same way you allocate, the same way you delete. You don't need this, but that's just for safeguarding, right? But you don't need this. okay, this is good enough. Because if you need this, right, means you did something wrong somewhere. And you don't. And yeah, it means I did something wrong somewhere. That's why I put this here. But you don't need it. Okay? If you do everything correctly, I'm going to show you how you're going to do everything correctly. Yeah, clean code. Okay, so now moving on to our operator overloads. Same thing, vector this. You can use a template if you want. So for this one, they're both no, actually you can't use template, they're doing different things. Okay, so for this one, vector reference, if you're returning a vector reference, this is copy assignment, right? Copy assignment. What does the HPP file say? Copy assignment. So we listen to it. So what you're going to do is that we're gonna take the value from this vector RHS. We're going to copy it into this return vector. So first of all, correct. So what this does, right, you're not initializing a new vector, you are copying one vector to another. A equals to B. Okay, so B will be into A. Maybe I can illustrate that with one of the outputs file. Let me see if I can open it up. Output. Yes. Shit, did I close something? I don't know. I think it's fine. Okay, so for test push, test subscript, test copy. Subscript, then go through subscript. Not yet, it's over here. Okay. So test copy. So for this one, is the copy. Yeah. So what you're doing is that you're just gonna copy A into B, and then just print both. And then copy B into C, then you print both. So they both should be the same since you just copied both of them. Right? But notice the one difference is the allocs. You don't copy allocs. You don't copy capacity. You see, they're different. You don't just blindly copy. You must think. What happens when you copy? What happens to the array? So let's just go through the code first. Or maybe no. Let's go through what you need to know. So for this one, right, what happens here for A is that when it was called in vector driver for test copy, see, it started out as how to say, yeah, it started out with empty alloc. Then for every time you push back, right, you need to increase the alloc, right? So you just keep increasing for size, then just you continue increasing until it becomes 16 over here, right? It makes sense. You install one. Oh, hold on, my cat's on the desk. Okay, so let's say you copy the first one, then it becomes 1. Then when you increase another one, it becomes 3 because you put 2. Then you increase one more, then it becomes 10. Then blah blah blah, and then it becomes 1, 2, 3, 4, 5, 6. 6. It becomes 15. 6 becomes 12. No, I think I do something wrong here. 0 equals to 1, then 1 equals to 2. 1 plus 2. No, 1 equals to, yeah, plus 1, then plus 4, then 4 plus 8, yeah, then 8, then it becomes 16. Yes, you guys get it so far? I must draw it out. I think I didn't draw it out. I think I lost some people there. So what happens, right? Remember that our reserve function, if size, oops, that's the eraser. If size equals to space, these are in our reserve function. Reserve new alloc. Okay, it's not size equals to space. It's space equals to new alloc. Wait, no. What am I doing? Pushback, and then we have a new value n, right? So when you push back, you check if size equals to space. If size equals to space, then you reserve 2 times more space, right? So, and then there's a first function on top also. If size equals to 0, reserve 1 space, right? Okay, so let's start. Let's imagine a empty vector. So empty vector, our size is equals to 0, so we reserve 1, so it becomes a space of 1. So here it says 0, right? So now our size equals to 1, our space equals to 1, right? And then let's continue. So now we are pushing back 10 integers, and they're running in a for loop in the vector driver. Can you see it? Yep. Okay, just like that. Right, they're running in a for loop. So this is first loop, second loop. Pushback. This is pushback 1, then pushback 2. Pushback 2, we come into an error because size now equals to space, right? Size equals 1, space equals 1, so they are the same. So we need to reserve 2 times the amount of space. What's 1 times 2? Right, 1 times 2 is 2. So now the new value will be, they never put a new value here. I think it's just going to be 1. Because plus, yeah. Right, so now we have initially increased, it's not equals. So now our size has increased to 2, and our space has increased to 2. Got it so far? But see, the size and space are still the same. So what you're gonna do, so when you call pushback again, it's gonna run the first line again, reserve 2 times space. So now when we reserve 2 times space, I'm not going to write all the values again. Size equals to 3, right? You increase the size by 1, but you increase the space by 2 times. So now it's 4. Okay? So now the space is 4. Then you increase by 1, then it's still the same, 4, nothing changed. But if it's 5, you times 2, become 8. Then go all the way until size equals to 8. Let me not do that. Dot. They're the same. They're still the same at 7 and 8. They're still the same at 7 and 8. But once you reach 8, after you reach 8, you have 9. They are the same, so you're going to increase this by 2 and 16. Then you end at 10. Okay? Does this make sense? I hope it does. So that's why our output here, we have capacity 16. Oops. That's why output here, we have capacity 16. And then, but then when we copy the value, right, we're not going to assume that the vector, the new vector, we don't care about the free space, right? That would not make sense that we copy the free space as well. So we just make the capacity the same as the size, right? This is a different vector with a different number of allocations, so you don't copy the same allocation. Since you only copy it, you are creating a new not a new, but you're creating a, you're just allocating once, so it's just plus plus. If it was 0, it will be 1, and that's it. Then same thing here. What happens here is that they just copy it. Yeah, they just copy it. So since B was originally this, C will just be the same. But this is not the same. They don't copy the allocation. It just so happens to be 1. But the size and capacity is the size and is the size. Okay, capacity is the space. And then yeah, simple stuff. So what we do here for vector copy assignment, yes, the space will equals to the space of RHS of the input. You increase the allocation by 1, and then there's a few things that we have to know, and it's listed in the PDF. PDF is your friend, and your copy assignment operator right here. See? But what about consider you don't care about the thing. The new vector will get a copy of elements, but since you don't assume how it's going to be used, so you don't bother with the extra space at the end. So what you do, right? Just follow the steps here. Allocate memory for a copy. Copy the elements. Delete the old one. Remember, delete the old one. Set data to the new pointer, and then set space to the new values. But what if they have the same number of elements as the vector? So what you do, you don't care about creating a new array, right? Because look at it this way. If the size is the same, the space is the same, right? Wait, if the size is the same, you don't need more space. You don't need to create a new array to store the new space, because you don't need to increase anything. Right, it's really the same. It's really the same amount of elements. So what you're going to do is you're just going to take whatever of the input you put into the current one, the one you want to. So if size equals to this, you just copy, right? So see, this is the time you're going to use copy again. You just copy, and then you just return this. This referring to the vector that is on the left hand side. Okay, on the left hand side. Okay. Oh, this is copy assignment. This is test assignment on the left hand side. Yeah. I think I went through the wrong thing. Okay, never mind. No, it's still correct. Okay, so now space equals to the right hand side of the space. Increase the allocation, and then all this. Size equals to, if they are the same, right? You don't care about this already. You already exit the function already. But if they're not the same, you just you make sure the size are the same. You delete the old data. You put in the new stuff. You create a new array based on the size that your new vector is currently. You copy again, very useful, and you just return this. That's it. So just a slight difference. If size is the same, you don't need to create a new array. Okay. And remember, delete data, very important. For this one, initializer list, there's nothing much to do. Yeah, size equals to size, space equals to space. Because for initializer list, right, you're not copying a vector, you're copying a list. When you copy a vector, it's more complicated. When you're just copying a list, storing a list, it's just copy. You wanna copy the list, you just copy. Size equals to size, space equals to space, increase the allocation by 1, then create a new data, and then copy, and then return this. That's it. You can't use this. You can't use this because this is not a constructor. This is an operator overload. So you can't use this to shortcut. I tried it, doesn't work. This is not a constructor. So you have to do it one by one. And then you return this. And copy again. See how useful the copy function is? I feel like forgetting something. Oh, subscript. Yeah. Subscript. Subscript, you want to return the data inside, right? So just return the data inside. That's it. This okay, if to explain it properly, let's do it at the driver that test it. Yeah. So if we want to run it, yeah. Sorry, also getting the mic. So this is a subscript operator. I is whatever in it is value type. Very useful. So so this I is your index. So your index will point to the current data that you want to access. So you just take the index, you put it inside your data pointer. Remember this is a pointer, right? So you just return it. That's it. Same thing here. Just make sure to cast it const. You can do it the same way but it's good to have concast here. Concast reference, static cast vector, const reference, then this belongs here. Then you reference this. You reference this to get the index. That's it. Simple stuff. You can make. It's fine. You can make tests. Oops. Oh, I got a never comment out. Comment. I did comment out. I never save. Oh, there's an error. What's wrong? Never mind. I'll pass you guys this make file. There is make. Then just make compile. There is make debug. There's make test to diff. Make to differentiate the thing. There's a make debug, so you can see what's going on. Test push. It's only running test push. That's not right. Save this. Save. It's saved already, right? Yeah. Why is it not running properly? Hang on. This should be on the drive. It's only running a test push. It's not running a test subscript or anything. Oh, got here. This is a what you call it? Sort of it's running all these function tests. But if I don't, this is like a function pointer. So the function name is here. Then you run the function here. But I only put 1, so it is only running test push. If I put 2, it will run test subscript as well. But I want to run everything. So let's change it back to 5. Yeah. So make debug, you can see all the message. Make test, you can do the run the diff. If nothing is wrong, you won't have the error message like over here. Error. Okay, and then you can test the bug grind. And then 44 allocs, 44 free, no leaks possible. Perfect. I feel like I'm missing one important factor. I remember there was some memory leak somewhere. It was very strange. But if I thought really hard about it, I could solve it. just keep in mind when you allocate when you create a new temp memory, a temp when you create a new temp array, not a temp pointer, when you create a new temp container, always always make sure to delete the memory once you're done. Okay, delete the one that you're not using. And then I think that's about it. Do you guys have any questions for this assignment before we move on to the lab, or are you guys done for tonight? Because this went on for quite long. Continue on. Alright. Okay, one tip for commenting, right? What I heard from Jeremy is that function level, file level is important. Function level not so important. If you just need to comment here, it's important. You just need to comment here, right? For each function, vector, explicit. Just keep that in mind. And then yeah, if they are overloading, you just need to comment once only. Okay? This one don't have to. You don't have to. I think you know you have to. This is technically overloading. No, overloading just save the commenting. Since they're doing the same, the functions are doing the same thing anyway, right? Yeah, maybe just say number function overload or something overload. Then just make it nicer. Don't copy my comment. Definitely do not copy my comment. It'll be too obvious. Alright, so let's move on to the next one. Give me time to set up. Oh, just stop recording.